Hello everyone, myself Dr. E. Sridevi, Professor, Department of Biomedical Engineering. In this video lecture, we are going to learn about mathematical modeling of electrical systems. First, we have to know modeling of electrical systems. It is a process of developing a mathematical representation of electrical system so that its behavior can be analyzed, simulated and controlled by any type of device. So electrical system models are widely used in power systems, control systems and biomedical instrumentation, communication systems and electronics. So here the steps of electrical systems. First one is identifying the circuit elements, then choosing the output variables. Third one is applying Kirchhoff's current law and Kirchhoff's voltage law. Form the differential equations and taking Laplace transforms. Then finally obtain the transforms or final function that is called as transfer function. The need for modeling of electrical systems. What's the need of modeling is electrical system modeling is needed to understand the behavior without physical experimentation. Then predict the system response to inputs. Analyze the stability and transient and steady state performance of the system. So design controllers and compensators. Reduce cost and risk in the system. There are three basic electrical elements in this system. So these three basic elements are RLC, that is resistor, inductor and capacitor. So first one is based upon resistor, which follows Ohm's law. That is V of t equal to R into I of t. That is energy dissipated as heat. That is according to resistor element. Then second one is the inductor. As per inductor, the voltage current relationship in an inductor is given as that is V of t equal to L into di by dt. So it stores energy in the magnetic field. Then third is the capacitor. The current voltage relationship of the capacitor is given as I of t equal to C into dV by dt. Capacitor stores energy in the electric field. So steps in modeling an electrical system. So first one is identifying the system components, that is R, L and C. Then second one is applying physical laws, KVL or KCL. Third is deriving the electrical differential equations. And fourth one, converting the equations into mathematical models. Fifth one is represent model in suitable form, that is differential form or transfer function or state space model. Then validate this model. This is the mathematical models of an electrical system. So first one is differential forming and differential equation model derived using KVL or KCL. So considering one series circuit with RLC elements, so this Laplace time domain behavior of the system can be written as L into d square I by d square I of t by dt square plus R into di by dt plus 1 by C into I dt is equal to dV of t divided by dt is called as time domain behavior of the system. Then transfer function model of the system. Transfer function model of the system can be given as the ratio of Laplace transform of output to the input, that is the initial conditions are assumed to be 0, that is G of S is equal to, that is given by output divided by input. Then advantages, simple representation useful to control and stability analysis, and limitations are it is applicable only to linear time invariant system, that is LTI systems. So main this state space model is given as x of t equal to a of t plus b into u of t plus y of t equal to cx of t plus du of t, and these state variables are u of t input and y of t is the output. Advantages: it is used in memo systems and suitable for nonlinear systems and used in model control system devices. This block diagram representation shows the signal flow graph, and the electrical systems which is used for modeling this is, which is the element is called as RLC. What we said this are given as the table here: current and voltage relationship between resistor, inductor and capacitor. So here this all are the, by using these equations mathematical modeling is possible with the circuit description RLC. This session clearly defines the modeling of a series RLC circuits with the current and voltage relations. Hope you all understand this session. Thank you for listening. So here there is one solution, one example, solved example. In this example, we are having one circuit diagram with RLC, and here we have written this output input relationships and with the transfer functions by the voltage divider rule, and replacing the capacitor by 1 by SC, and this V naught of S output functions can, and input relationship can be written like this. Taking output divided by input is like this. So this is the one function, and another one example, same thing here. More inductors and more capacitors are here. Here also we are writing this Laplace transform and bringing the relationship between this input and output. So final answer will be relationship between E of S divided by I of S. So here taking and simplifying these expressions, and we are having the result like this: output divided by input. So here we are having the applications as power supply circuits and control systems, communication systems, biomedical instrumentations and signal filtering circuits. And advantages are: simplifies analysis, enables simulations using MATLAB or Simulink, and which is used to reduce this error. Hope you all understand this session. Thank you.